All right, so we're going to determine the empirical formula of a compound. And then here's our two percentages. So here's the first step. This is a whole little chemistry assume thing. I promise it works. Assume you have 100 grams of sample. So if you have 100 grams, 82.6 grams would be 82.6% would be this number right here, this 82.6 grams. Do you see that? Because it's a 100 gram sample, we're assuming. So it automatically makes our percentage into a gram amount. You can put it in a calculator too if you don't believe me. Do 82.6 divided by 100 to turn, your percent times this 100 number, and you're going to get the 82.6. You're going to do that for everything that's given to you as a percent. So basically we're just saying rewrite the percent unit as a gram. If you didn't like thinking of it the way I was just saying it, just rewrite it as a gram. You got to have a gram to move forward. And also, like I said, some problems will just give you the grams, so you don't have to do this. You're already given that number. And you would be starting at step 2. So step 2. All right, so here's the key thing. These are mole ratios. Those little numbers, that go at the bottom of a formula, they're mole ratios. So we have to convert grams of each element in the sample into moles. Once we do that, we should have the formula. So you're going to divide by the molar mass. Remember, you can call that other masses, but that's the number off the periodic chart. So here we go. We got 12.01. Again, this is from the periodic chart. Same with this one, periodic chart. Hopefully you're starting to accidentally memorize some of these. And when you do that, you get 6.87 and 17.2. But look, we've talked about this tons of times. You can't have a decimal in here because it implies that you have like part of a carbon atom, and you can't have part of a carbon atom. You either have it or you don't. So we can't have those numbers. And this is one case where you can't just round up. It's the rule you cannot just round. It doesn't work. So like our normal rounding rules, this is one category where it won't work on. So we're not allowed to round up or round down. We have to do something to get these into whole number ratios, and this is a little math trick. It converts all the mole amounts of each element. To convert all the mole amounts to each element if it's not the lowest ratio. So notice what you're going to do is you're going to divide each mole amount by the smallest number of moles, and you'll round up only after this step if it's in the 10th place or in the ones place. So the reason I picked the 6.87 is because when I compare that number to that number, the 6.87 is the smallest. So everyone gets divided by him. Joop, joop. Oh look, I get a whole amount of a carbon. That's awesome. So I'm most of my way there. So usually this works and you can stop right there. But in this case, and of course I picked an example that doesn't work out right. Most of them will. It's still not okay. Can you see the whole number ratio? Can you guys see it? 1 to 2.5. It's going to be 2 to 5. You might be able to, it might be that simple for you. If not, then here's the words that say it. This final step is only necessary when the 10th place of one of the answers is something that has a number that ends in a 5 or a 3. You can't use normal rounding rules. So if it ends with like a 0.5-ish, you're going to multiply by 2. If it ends in a 0.33, you'll multiply by 3. So I'm going to take this top number. Here's the number I have. And I'm multiplying, because it ended up that I had one number that had a 0.5. I'm trying to get rid of that 0.5 is what I'm trying to get rid of. So I'm multiplying everything by 2. So the 1 mole of carbon becomes 2 moles of carbon. And the 2.5 moles of hydrogen becomes 5. Like I said a minute ago, you probably already could have seen that just by looking at it, that ratio 1 to 2.5 is the same thing as carbon to hydrogen 5. And if you like a visual, so if you don't like all the words, there's a nice little visual right in here. It's got the pictures. You got your mass, you divide by the molar mass, by the lowest numbers, convert to the whole number ratio. If this works better for you, then you can use it. I just want to make sure you had that resource.